It's okay.
Okay. Okay. Good day, dear participants of the conference. Today I want to represent the paper that is called State-Based Sandbox Tool for Distributed Malware Detection with Avoid Techniques. My name is Paulo Rihida and I will represent this work. According to the latest scientific studies, the impact of computer viruses is increasing every year, with both the number of viruses and their types that are continuing to grow. The most modern computer viruses are aimed at obtaining user personal and business information or even corrupt it so that it becomes unusable in the future. This picture represents the growth in the number of viruses with the data provided by AV-Test company. Today, information technologies offer a variety of methods widely used in malware detection tasks. This approach involves the analysis of potential malware, which can be divided into three basic methods known as static, dynamic, and hybrid. And sandbox environments and emulation technologies have proven the highly efficient in detecting and analyzing the malwares. To hide the activities of computer viruses, malware developers employ various techniques that known as evasion techniques or even avoid techniques. Some of most commonly used techniques include the anti-emulation, anti-analysis, anti-debugging, anti-reverse, and more. This paper will primarily focus on two major techniques, anti-emulation and obfuscation, and how they can be implemented into viruses, and the problem, how we can how we can to detect them. Uh, let's concentrate more on avoid techniques that belongs to both of these categories. And anti-emulation techniques are commonly used as a tool to understand if malware is emulated runs in emulated malware environment. I'm sorry. Depending on this, malware can hide its own action to be not detected. Example of these techniques are searching the virtual tools, timing analysis, hardware checks, system call analysis, checking the file system. So basically, virus may check the system and try to understand if emulation is on and will hide itself. Another approach that will be discussed here and analyzed is obfuscation techniques, and they are used to change the signature of the malware, so it will be hard to detect while analyzing. And we have six major obfuscation techniques that are widely covered in most of scientific works, and they are code insertion, register reassignment, subroutine reordering, code transposition, code integration, and instruction substitution. Okay, so sandbox and emulation techniques are widely used approaches in the problem of malware detection. Combination of both allows to run potential malware in isolated environment. In this case, sandbox encapsulates the emulator workflow and process begin being executed on it. Both of technologies allows to control over the execution process of potential malware, thereby detecting most malicious actions. Uh, the main advantages and disadvantages of using this sandbox is described on this slide. So to the main advantages is security isolation, behavior analysis, and dynamic analysis. On the other hand, we have some disadvantages, and the key of them are resource overhead and complexity. We in this work we present some base sandbox, and it was developed to run an emulator for that can implement and run some low-level instructions. The current solution supports several registers that are commonly used in most of modern CPUs, such as X, Y, PC, and SP, and the accumulator and internal memory. The developed emulator supports a set of widely used low-level structures, and the list of them is described. Generally, a proposed solution allows to emulate the process of launching the list of low-level instruction, and then it can be used for detection the performed malicious actions. Um, if we, I suggest that we are talking about two avoid techniques, and if malware can have them, so we can describe five modes of how this malicious can run: hiding, aggressive, safe, normal, and pause mode. And their difference is the most dangerous one is aggressive mode that and shows that when emulation was detected and obfuscation code was not used, but malicious program was launched. So state approach as detection tool. The primary goal of some malwares is to take the control over the launching program. To detect the moment when such is lost by the main program, it is suggested to use emulator state. Emulator state represented by values that is stored inside each register and CPU memory. Malwares that uses avoid techniques may change its behavior depending if emulation is detected. So if this difference is detected, that means that malicious actions were performed. What is analysis? How can we analyze the state? The general idea is to launch the same potential malware software in different states. After executing the tested application in proposed to real values that is stored inside a register and internal memory. This is possible with using the software interrupts. After performing these interrupts, the sandbox gets the values from the emulator and gets the hash value. Such operation performs every 5 instructions that obtained from the list of codes that contains low-level instructions. Uh, as I mentioned earlier, that one of the biggest disadvantage of using the emulation that is requires a lot of computing resources, and also we are adding additional checks because we not only check in traditional way the program, we want to check it in different states. So we need a lot of computational power in order to check everything what was discussed. So we decided to use the distributed model, and this distributed model are used to share these states to be checked on different clients. Uh, some results of our work is, for this work it was used distributed system that has one server node and 3 client nodes. It was generated as several lists of codes that was distributed between all clients. For this paper, the same state was checked on all client nodes. Results shown the distribution should be considered again to get more efficient result. So we have took 6 different avoid techniques, and we get some additional files that are represented as virus, and we try to launch it on 1 machine, 2 machines, and 3 machines. Because our distributed system is designed as um, system that will be used for as kind of volunteer computing, we have to check if each node gives the right answer. So when we use distributed approach, we need to use redundant execution to get additional result and check if all clients do the same job correctly. Uh, Future researches. After performing several launches, we define next improvements that should be done. Researching a new anti-emulation methods make current emulator more complex so it will be able to perform additional instructions, implement a voting system into server application, and find optimal size of tasks that should be sent to the clients in order to optimize the efficiency of whole system. Thank you.
Thank you, Pavlo. Colleagues, any questions, please? Okay, I have one. Pavlo, can you say your sandbox is developed to Linux, Windows, or iOS? What kind of operating system, or it's cross-platform as an approach, or you have some exact realization?
Well, on this stage of the project, this sandbox uses emulator that doesn't have such kind of operation system. It is approach that is used to launch some low-level instructions, and on this case, we are launching real instructions that are uh, using on real development, on real equipment. But we need to make it more complex in the future researches.
Okay, thank you. Dear colleagues, any more questions? No? Okay. Thank you, Pavlo, for your presentation.
Thank
It
you.
was very interesting and fruitful. Thank you. Okay. I'd like to say that our session ended. Thank you for your presentation. See you tomorrow in other sessions. Bye bye.
Thank you, and thank you for meeting of this subsection. Goodbye.